Hello, my dear students. Welcome to Sankalp Learning Classes. Today, we are going to solve the 4 to 5 mark questions from the electricity. Okay. Yes, let us start with the first question. Yes, let us start with the first question. Already we have solved the 3 mark questions, 2 mark questions. So, in the last video, yes. An electric heater connected 220 volt generator draws the current 10 ampere. What is the power of electric heater? If it is used for 8 hours a day, then calculate the total cost of using 30 days, rupees 5 per kilowatt. Okay. Yes, here. An electric heater. So what is the voltage? That is equal to 220 volt. Then generator draws the current of 10 ampere. What is the current? I is equal to 10 ampere. What is the power of the electric heater? So first we have to find out power. Okay, let us find out the power. What is the power of the electric heater? That is the first question. So what is the formula? First you should write down the given data, then find out the power. P is equal to V into I formula you can use here. Okay. P is equal to V, that is 220 into what is I, that is 10 ampere. Okay. So what is the power? That is equal to 10 0 0 10 to the 20 0 to 10 to the 20 22 2200 ampere. Sorry, 2200, not ampere, watt. Okay. So what is the power of the electric heater? That is 2200 watt. Okay. So this is the power of the heater. If it is used for 8 hours in a day, then calculate the total cost of using 30 days at rupees 5 per kilowatt hour. So this power electric heater that is used 8 hours a day up to 30 days. What is the cost we have to find out? Okay, so now I will remove these all things. Okay, only 2200 watt, right? What is the power? That is 2200 watt. Next, what is the time? That is 8 hours. How many days? That is 30 days. Then 1 kilowatt hour is equal to, that is rupees 5. Okay. Rupees 5. Now you have to find out the energy consumed by the electric heater for 30 days. Energy consumed by heater. Energy consumed by heater for 30 days, in 30 days. Okay. So that you have to write properly. So what you have to do? 220 volt, sorry, 2200 watt, 2200 watt. Then what is 8 hour? Then total 30 days. So this you have to multiply 800. So first I will multiply this 800, 8 to the 16, 1, 8 to the 16. 17,600 into 30 is equal to 300, 0, 18, 1, 2, carry 2, 3 ones are 3 plus 2, 5. Okay, so that is total 52,000, 5 lakh, 28,000, total 1, 2, 3 zeros. Okay, just I will clear these all things. So just multiply it, that is, what is the value? So just write down, multiply this 5 lakh 28,000. Okay, watt hour. Okay, then here 1 kilowatt hour is equal to 5 rupees. So it is in watt hour. You have to convert it into a kilowatt hour. You have to divide it by 1000. Okay, so when you divide it by 1000, 3 zeros get cancelled and it will become 528 kilowatt hour. Okay, so what is answer? 528 kilowatt hour. Then, so what is the cost? 528 into 5 rupees. Just multiply this. 5 is a 40, carry 4. 5 2 is a 10, 14, carry 1. 5 5 is a 25, 26, 2,640 rupees. So this will be the answer. What is the cost? That is 2,640 rupees will be the cost. Yes, so like this, in this method, you have to solve the question. Next question. A wire of given material having length L and area of cross section A has the resistance 4 ohm. What would be the resistance of another wire, same material having the length L by 2 and area of cross section 2A? So please note down the answer question. After that, you have to try to solve the question. Here, the first wire, that is R1, that is having the rho into L by A, that is equal to 4 ohm. For the second wire, so that is equal to L by 2 and that is 2 ampere, right? So you have to, what you have to find out? So that is 1 by 4 rho into L by A. So R2, that will become this. Okay. So that is equal to 1 by 4 into R1. R2 is equal to 1 ohm. The resistance of the new wire, that is equal to 1 ohm. So like this, you have to solve it. Next question. In an electric circuit, the resistors R1, R2 and R3 have the values 5 ohm, 10 ohm, 30 ohm respectively. When these resistors connected to the battery, 12 volt battery parallelly, then calculate the total resistance of the circuit. This is also 5-mark question. Here, first thing is you have to note down the given data. R1 is equal to 5 ohm. R2 is equal to 10 ohm. R3 is equal to 30 ohm. Okay. Yes. When these resistors are connected to a battery, so voltage V is equal to 12 volt. So here they mentioned they are connected parallelly. When they are connected parallelly, to find out the total resistance, what you will do? You have to use the formula 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So 1 by Rp is equal to 1 by 5 plus 1 by 10 plus 1 by 30. Okay. So I will write the next step here. So you have to 1 by Rp is equal to here 30, 10, 5. So LCM that is 30 divided by 6 plus 3 plus 1. That is equal to 10 by 30. So that is equal to 1 by 3. Rp is equal to the total resistance is equal to 3 ohm. What is the total resistance? That is 3 ohm. Okay. So then calculate the total resistance of this circuit, that is 3 ohm. Next question. A bread toaster rated 350 watt is used for 15 hours a day. An electric iron box rated 250 watt used 5 hours a day. Calculate the cost of using these appliances for 30 days if the cost of 1 kilowatt hour is rupees 4. Here rated 350 watt. So what is the power of this bread toaster? Bread toaster, that is 350 watt. And what is the time per day? Time, that is 15 hours per day. And power of iron box, that is 250 watt. And what is the time used per day? That is 5 hours a day. And what is the value of 1 kilowatt hour? That is equal to rupees 4. So these all given data you have to write. Okay. After that, so now I will start to solve this question. So just I remove this. We'll take the new page. The energy consumed by heater up to for 30 days, that is, what is the power? That is 350 watt into how many days? 350 watt of 15 hours, 15 hours into 30 days. What is the energy consumed by the electric heater? Just multiply this 350 into 15, 350 into 15 into 30. That is equal to 1 lakh. Just directly I will write the answer. To people, just multiply this, okay? 1,57,500 watt hour. Okay. Then same energy consumed by iron box in 30 days. Okay. 30 days. That is, what is the power? That is 250 watt into 5 hours per day. That is into 30 days. Just multiply this. 500, 5 5 is 25, 2, 5 2 is 10, 12 into 30. That is equal to okay, 37,500 watt hour. The total energy consumed by the iron box, that is 37,500 watt hour. So you have to add this both. Okay, so you have to add both 1,57,500 and 37,500. So just add, you will get 0, 0, 0, carry 1, 15, carry 1, 9, 1,95,000 watt hour. What is the total? So you have to find out total energy consumed by heater and the iron box. That is 1,95,500, 1,95,000 watt hour. So you have to convert it into kilowatt hour and divide it by 1,000. Okay, 1,95,000 when it is divided by 1,000, 0 0 0 0 0, that is equal to 195 kilowatt hour. 195 kilowatt hour. Then what is the cost of 195 kilowatt hour? So 1 kilowatt hour is equal to rupees 4 rupees. So 195 kilowatt hour is equal to, so just I will write here, 195 into 4, that is 5 4s are 20, 2, 36, 38, 3, 7. Rupees 780 rupees. This is the final answer. What is the cost? That is 780 rupees. Okay. Next question. What is resistance of a conductor? On which factor, what factors does the resistance of the conductor depend? Then, is it advantageous to connect the electrical devices in parallel instead of connecting them in series? Why? Explain. Here, what is resistance of a conductor? So, resistance is a property of a material that opposes the electric current through it. Okay. So, on what factors does the resistance of the conductor depend? So, it depends on the resistance of the conductor, that depends on the length of the wire. If the length of the wire increases, resistance also increases. If the area of cross section of the wire increases, resistance decreases. Then second question. It is advantageous to connect the electrical devices in parallel instead of connecting them in series. Why? Explain. It is advantageous to connect the electrical devices. So we know in the 3-mark questions already we have solved this. Why parallel connection is preferred instead of series connection? What is the advantages of parallel connection? Okay, so now I'm not going to solve this. Next question. The resistors R1, R2 and R3 have the values 10 ohm, 20 ohm and the 60 ohm respectively, which have been parallelly connected to the battery 24 volt in a electric circuit. Then calculate the following. The current flowing through the each resistor, the total current in the circuit, the total resistance of the circuit. This you have to find out. Yes, here. R1 is equal to, that is 10 ohm. R2 is equal to 20 ohm. R3 is equal to 60 ohm. Okay. R1, R2 and R3 is equal to 60 ohm. And what is V? V is equal to 24 volt. So what you have to find out? Total resistance, total current and current through the each circuit, that you have to find out. Okay. So let us find out the total resistance when it is connected parallelly. So we can use the formula 1 by R1, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 formula. Okay. Yes. So here 1 by Rp is equal to 1 by 10 plus 1 by 20 plus 1 by 60. Okay. So next. So what is the LCM? 60 divided by 6 plus 3 plus 1. 1 by Rp is equal to 10 by 60. 0, 0 get cancelled. Rp is equal to 6 ohm. Rp. What is the total resistance in the circuit? So you have to write the total resistance in the circuit, that is 6 ohm. Then let us find the, what is the current? Total current V is equal to I into R formula. So I is equal to V by R. You know this formula. Okay. I is equal to V, that is 24, and R, that is 6. I is equal to 4 ampere. The total current flowing through this circuit is 4 ampere. Then current flowing in each resistor, current flowing through the each resistor. So from R1, R2 and R3. So when it is connected parallelly, current flowing through each resistor, that will be different, right? So current flowing through the first resistor, R1 resistor, that will, I will take it as a I1. I is equal to V by R1, right? So I1 is equal to 24 volt divided by 10, that is equal to 2.4 ampere. The current through the first resistor I1, that is equal to 2.4 ampere. I2 is equal to V by R2, that is equal to I2 is equal to 24 divided by R3, that is, sorry, R2, 20. Here it is equal to, this is equal to 20, 20, 1.2 ampere, I2. Then I3 is equal to V by R3, that is equal to 24 divided by 60. What is 24 divided by 60? 60. Just a minute. 2.4 divided by, sorry, 24 divided by 20, that is equal to 1.2. So here 0.4. Here 0.4 ampere. Okay. So this is the first thing. You have to write it in a sentence. The total resistance in the circuit, that is 6 ohm. The current flowing through the circuit, the total current flowing through the circuit, that is 4 ampere. The current flowing through the each resistor, that is I1 is equal to 2.4 ampere, I2 that is 1.2 ampere, and I3 that is 0.4 ampere. Okay, so that is the answer. Next question. State Ohm's law. In domestic electric circuit, the electrical appliances are not connected in series. Why? Write the factors on which resistors of the conductor depend. So this is also a 4-mark question. Ohm's law. So what is Ohm's law? So that also we have solved in the, please refer the previous video for this definition. Why? And the second question, in domestic electric circuit, series connection. So the appliances are not connected in series. That is also we solved in the last question. Yes, so this is the answer. Write the factors on which resistance of the conductor depends. So this question also we have solved in the last question. Resistance of the conductor depends. Yes. What are the advantages of connecting the electrical devices in parallel in an electric circuit instead of connecting them in series? Yes. So a parallel circuit divides the current through the electrical gadgets. The total resistance in a parallel circuit is decreases. This is helpful particularly when each gadget has the different resistance and requires different current operate properly. Then if one electrical device is damaged, it will not affect the other devices connected parallelly. Hence the other devices continue work properly. The voltage across each electrical device is the same, and so the device can take the current as per its resistance. Voltage is same, but it can take the resistance as per its current. How are the ammeter and voltmeter connected in electric circuit? What are their function? Here, ammeter that is connected in series and voltmeter that is connected in parallel. What are their function? Here, ammeter that is used to measure the rate of current in the electric circuit, and voltmeter that is used to measure the potential difference. Potential difference. Okay. Next question. What is the meaning of statement? The potential difference between 2 points is 1 volt. This is the 5-mark question. Okay. Name the device used to measure the potential difference. The resistance of a conductor. Okay. And what is electric power? Write the 3 formulas used to find the electric power. Here, what is the meaning of the statement? The first question is, the potential difference between 2 points is 1 volt. What is the answer? 1 volt is the potential difference between the 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to the another point. So that is the first one. Name the device used to measure the potential difference, that is voltmeter. What is the resistance of the conductor? So the third question is, what is the resistance of the conductor? So resistance of the conductor is property of the conductor that opposes the flow of charges or current through it, which opposes the flow of current through it. Okay. Then next question is, what is electric power? What is electric power? The rate at which the electrical energy is transferred or consumed in an electrical circuit is called electric power. So what are the three formulas used to calculate the electric power? That is P is equal to V into I, P is equal to I square R, P is equal to V square by R. So these are the three formulas used to calculate the electric power in the circuit. Okay, so this is the 5-mark question. An electric refrigerator rated 400 watt is used 8 hours a day. An electric iron box rated 750 watt is used for 2 hours in a day. Calculate the cost of using these appliances for 30 days if cost of 1 kilowatt hour is rupees 3. The power of the, just write down the given data. What is the power of refrigerator? 400 watt. Please note down the given data for solving the question. The power of the refrigerator, that is 400 watt, and power of the electric iron box, that is 750 watt. So refrigerator used per day, that is 8 hours, and iron box that is used per day, that is 2 hours per day, and total 30 days if the cost of 1 kilowatt is rupees 3. So these all things you have to write down to solve the question. Okay. Yes, first thing is, I will write shortly, energy consumed by a refrigerator for 30 days. Okay. So energy consumed by refrigerator for 30 days. What you have to do? 400 watt power into how many hours per day? That is used 8 hours per day. 8 hours per day into how many days? 30 days. Okay. So just multiply it. 400 into 8. 400 into 8, that will become 3200 into 30. So you can multiply it easily. So I will write the direct answer. So this multiplication answer will be 96,000 watt hour. Okay, so this is the first one. So here, energy consumed by iron box for 30 days. That is, what is the power? That is equal to 750 watt. So that is used 2 hours per day, 30 days. Okay, so just check it once. 2 hours per day, 750 watt, 30 days. Okay, so the total energy consumed is 750 into 2. So that is 150, 1000 750 into 2, that is equal to 1500 into 30, that is equal to 45,000. 45,000 watt hour. Okay. Then total energy consumed by both devices, that is 96,000 watt hour plus 45,000 watt hour. So that is equal to 96,000 plus 45,000, that is equal to, please calculate this, try yourself, that is equal to 1,41,000 watt hour. Okay, so but now it is in watt hour. Convert into kilowatt hour by dividing it by 1000. Okay, so here 1,41,000 divided by 1000, that is equal to 141 kilowatt hour. You know that 1 kilowatt hour is equal to rupees 3, right? 1 kilowatt hour is equal to rupees 3. Then what is the cost of 141 kilowatt hour? That is equal to 141 into 3 is equal to 3 ones are 3, 3 fours are 12, 1, 423 rupees. What is the total cost of 141 kilowatt? That is 423 rupees. So like this you have to solve this sum. Okay, I hope this is clear. We have solved too many questions, this type of questions. Next question. A hot plate of an electric oven connected to a 220 volt line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately, in series or in parallel. What are the currents in three cases? Okay. So here I will take R1 is equal to 24 ohm. R2 is equal to 24 ohm. Okay. Here, what are the current in when they are connected in series, when they are connected in parallel, when they are connected separately? So when they are connected, so here, what is the voltage? That is 220 volt. Okay. So now I will clear this data. This you should write. Here, when they are connected in series, please write the formula. Rs is equal to R1 plus R2, that is equal to 24 ohm plus 24 ohm, that is equal to 48 ohm. What is the current? I is equal to V by R, that is equal to 220 volt divided by 48, that is equal to 220 volt divided by 48, that is equal to 4.58 ampere. 4.58 ampere. Okay, so that is the first case when they are connected in series. Next case is when they are connected in parallel. So 1 by Rp is equal to 1 by R1 plus 1 by R2. is equal to 1 by 24 plus 1 by 24, that is equal to 24 divided by 2, 2 ones are 2, 12. Rp is equal to 12 ohm, right? Here I is equal to V by R, that is 220 divided by R, that is 12. I is equal to 220 divided by 12. 220 divided by 12 is equal to 18.33 ohms. Sorry, ampere. 18.33 ampere. Okay, so that is the answer. And third, when it is connected separately, that is equal to R, total resistance is 24 ohm. So here I, you have to find out, I is equal to V by R. So I is equal to 24 divided by R, that is, sorry, V is equal to 220 divided by 24. So what will you get? That is the answer. Okay. Yes, like this you have to solve this sum. When it is connected separately and only when it is connected in series. One more thing you have to write is when it is connected in parallel. Next question. Show how you would connect three resistors. Each of the resistance is 6 ohm. So that combination has the resistance of 9 ohm and the 4 ohm. Okay. Here, three resistors, that is R1, R2, R3. These three resistors, they have the resistance 6 ohm resistance. R1, R2, R3 together, that is the 6 ohm resistance. And so this combination should be 9 ohm. You have to arrange this in a different arrangement, and combination should be 9 ohm and the combination should be 4 ohm. Okay. So if it is connected in series, so when it is connected in series, RS is equal to R1 plus R2 plus R3, that is equal to 6 plus 6 plus 6, that is equal to 18 ohm. Okay. So it will be 18 ohm. So it is not possible. When it is connected in parallel, that is 1 by 6 plus 1 by 6 plus 1 by 6. Just check it. 6 divided by 3. 3 ones are 3 twos are. So it will become 2 ohm. So it is also not possible. It is not a 9 ohm, 4 ohm. So now what you have to do? The combination of three resistors should be 9 and 4 ohm. First connect these two resistors in parallel. So like this, two resistors should be in parallel and one should be in series. Okay. So when two resistors are in parallel, apply the formula 1 by 6 plus 1 by Rp is equal to 1 by 6 plus 1 by 6, that is equal to 6 divided by 2. 2 ones are 2, 3s are. Rp is equal to 3 ohm. Okay. So when it is connected in parallel, then so again 6 ohm resistor is connected in series. So here Rs is equal to 6 ohm plus, so the total resistance of parallel resistors, that is 3 ohm, that is equal to 9 ohm resistance. Okay. So how you have to connect two resistors in parallel in the circuit and one resistors that should be in series, then it is total resistance is 9 ohm. Then second case is when two resistors are connected in series and one should be connected in parallel. Okay, one resistor that should be connected in parallel. So when two resistors are connected in series, Rs is equal to 6 plus 6, that is equal to 12 ohm. And this 12 ohm resistor that is connected into parallel to the another one, that is 1 by 6 plus 1 by 12, that is equal to 12 divided by 2 plus 1, that is equal to 3 by 12. Rp is equal to 4 ohm. So how you have to connect? So now it is 4 ohm. Two resistors should be connected in series and one resistor should be in parallel. Then the resistor total resistance will be 4 ohm. Yes, this is the answer. So when two resistors are connected in series, one in parallel, so you will get the 4 ohm resistance. Okay, so this is the 4 ohm it is. 4 ohm resistance. Next question. Compare the power used in the 2 ohm resistor in each of the following circuits. 6-volt battery in series with the 1 ohm and 2 ohm resistor and 4-volt battery in parallel with the 12 ohm and 2 ohm resistor. So when it is connected, 6-volt battery is connected in series, the total resistance Rs is equal to R1 plus R2, that is equal to 1 plus 2 ohm is equal to total 3 ohm resistor. Okay. Then what is the total resistance? That is equal to 3 ohm. Then, so you can apply the formula P is equal to V square by R. P is equal to V square, that is 6 square, 36 divided by 3, that is 3 ones are 3 twos are. What is the power? That is equal to 12 watt. Okay, so first one is the 12 watt and 4 volt battery in parallel with the 12 and 1 by 2 ohm resistors. So what you have to do here? 1 by Rp is equal to 1 by 12 plus 1 by 2, that is equal to 12 divided by 12 ones are 2 6, that is equal to Rp is equal to 12 by 7 ohm. So here V square by R formula, when you apply the V square by, so 12 watt, this is 12 watt. Okay, so V square, that is 4 square, 16 divided by 12 divided by 7. So 16 into 7 divided by 12. 9.01 something power. Okay, watt. So let us calculate this. Is here. When two resistors are connected in series in 6-volt battery, power that the total resistance is that is 3 ohm and the power that is equal to 12 watt. Okay. When two resistors are connected in parallel, so you can see here when they are connected in parallel for 4-volt battery, so you can find out the total resistance that is 12 by 7 ohm. And when you apply the V square by R formula, that is 9.33 watt. Okay. So the correct resistance is power is 9.33 watt. Yes, last question. State Joule's law of heating. Name two devices work on application of this law. Why alloy like nichrome used in electrical heating devices? Joule's law of heating, already we have solved that answer in the 3-mark question. What is state the Joule's law of heating? So again, I'm not giving the answer for that. Name any two devices work on the application of this law. Iron box and electric heater. Then, why are alloys like nichrome used in electrical heating devices? Because of high melting point, because of high resistance. Nichrome has a high melting point, it doesn't melt easily, and high resistance. So when heat up quickly when the current pass through this. For this reason, the nichrome is used in the electric circuit. This is also a 4-mark question. Yes, dear students, so these all are very important questions for your examination. Please practice these all questions that will be helpful for your board exam. Thank you.